Hello everyone, thank you for joining in. In our last video, we have created a minimal working example of using matplotlibcpp where we used STL vectors as containers to store the data we wanted to plot or visualize. In today's video, we'll use Eigen vectors to store data we want to plot. We'll also learn how to use semilogx method of matplotlibcpp library to represent the data along the y-axis of the plot. So without further delay, let's get started. So as usual, we'll start with including the matplotlibcpp.h. So we'll type hash include, then we'll type in the name of the library, which is matplotlibcpp.h. We'll also include cmath in case we need it. Further, we'll be using eigenvectors to store the data we want to plot, so we also need to include Eigen library. Eigen library is included as hash include within this greater than and less than sign. We need to type eigen slash dense. Okay. Then we create the namespace. We type plt is equal to matplotlibcpp. This is more or less the same that we have seen in our previous video, except the new inclusion here is this include eigen slash dense line. Okay. Now we'll create our main function, which is int main, and then we'll type return 0. Now we'll solve our first problem. Now the first example that we have is as following. We'll use linespace method of Eigen library to generate some data points within a certain range and have them stored in a variable of type eigenvector xt, and we'll plot their sinusoid values using matplotlib. So that's the plan for example 1. Okay. So we'll first create a vector x1, suppose, which is created as eigen scope resolution operator vector xt, and we name the variable as x1. Then we type eigen vector xt, then we call the line spaced method linspaced. Okay, then we create 200 data points between the range 0 and 6. Okay, next, so this is the data that we'll be plotting along the y-axis, x-axis. Now for the y-axis data, we'll first create a variable y1 where we'll store all the y-axis values. Next, we'll basically take x1 and then take for each values of x1 we'll be taking the sign values of x1 elements. So we'll have to perform x1 dot array, then the sign method. So in this way we'll have element wise signification of the elements of the x1, and finally the array will be stored in y1. And since we are using dynamical array vector xt for Eigen library, so it will be good here. Okay, so next we just need to plot. So for plotting in matplotlibcpp, we will be calling the figure method. Then, as same as before, we also need to find the actual, we need to call the actual plot method, which is x1. The first argument will be x1, the values that we want to plot along x-axis, then y1, the values along the y-axis. Next, we will provide the name of the axis label. So in our case, we type plt.x level and the name of the axis. In our case, suppose this is just x, and we also will have the label for y-axis, which we provide the name as sine of x. Okay, and these dollar signs basically convert the string into a LaTeX element. We can also provide the title, which is an example with Eigen library plus matplotlibcpp. And we can also call the grid method if we need it. Okay. So this completes our example 1. Next, as before, we need to export a couple of things to compile this program. We first need to export the LD library path. So again, this will be the same as LD library path. Sorry, didn't copy. Anyway, I'll type in. And then we will add the path that we actually want to append to this variable. In our case, this is home, username, then the environment in the Anaconda, so which is envs slash robotics is the name of the virtual environment, and then live. Okay. The next thing is we also need to export the name for Python home. In our case, that is within comma we need to provide the string of the path as a string, so which is /home username anaconda 3 envs / the name of the environment. Okay, now we have to provide the information to compile the code. So we need to type in the commands, so which is g++ -std is equal to c++ 11 -w -o. Then suppose we name the executable that we want to create is okay, then the name of the file is of this file, which is now we have to include a few paths as before. So it is done by -y, then /home /username /anaconda 3 envs name of the environment, and then the include folder, which in our case that is Python 3.7m. Okay, so the next include that we need here is we need to include numpy, because as we already know that matplotlib calls numpy behind the scene, so we need to have numpy as well. So -i /home /username, then the name of the virtual environment /lib Python 3.7, then site packages, then the name of the package, in our case this is numpy /core /include. Okay, we also need to include the Eigen library path. For this we'll provide the relative path from where I'm running the code. So this is one folder up from my current working directory. So we type -i / Eigen lib /3.3.8. This is the name of the folder, and then we now have to add the libraries. Now we need to add the Python link the Python libraries, and for that we need to type -l /home. So this is the library path where C++ will be looking for while linking different libraries. So for this we type -l /home username then environment in Anaconda, then we type lib and the file that we want to link, which is -l Python 3.7m and -l pthread, sorry. Yeah, I think we should be good here. So by now we should have our executable ready to run. So let's run the executable. Type dot slash matplotlib underscore basic2. Okay, if we run it, we do not see any kind of plot yet because we haven't called the plt-show method. So I think we are good now. Let's compile the code again and run the executable. Okay, so we see the plot, and since we have called the grid method, we also see the grid in the background, and this is the sine plot. And we have made a small mistake because as we can see that y-axis has y label has no name and the x-axis has named wrongly, so x-axis label should be named as x and y-axis name should be named as sine x. So we have some typo here in our code, just correct it and recompile the code. Okay, so we now have our x level and y level names fixed. We also have the nice little plot for x versus sine x. Okay, now we'll get to our next example. The next example is pertaining to the understanding how to use multiple sequence of element-wise operations on a vector xt variable and then plot it in matplotlibcpp. So this is little bit more involved in a sense that we'll be calling multiple functions over a single eigen variable. Let's see how it's done. So we'll first create a variable called y2 to store the newly generated variables elements. Sorry. So type eigen vector xt. We name the variable as y2. Then we name the variable name as then we perform the computations over x1 variable. So we take x1, then call the array method, and then we call the cos method. And also after we have all the cos values of all the elements in x1, we then exponentiate all the cos values. So we do cos and then exp. So as you can see, we can have multiple functions imposed compounded one top of the other whenever we have a variable x1 as eigen x vector xt. So that's a great utility. So we do not need to write down multiple lines of code. In one line of code we are actually calling multiple methods, one on top of the other. So we then type figure and then also plot the values of y2 along the semi-log x as the semi-log x. So we called semi-log x so whatever value of x1 that we have will be as will be plotted in the log scale, and the y values will be plotted in the actual scale. So it will be clear later. So let's type in the arguments that the semi-log x function takes as input. Then we provide also the line style, and line style is provided as dash dash. Next, we just provide the name of the X label and Y label and the title, and we probably also would like to call the grid method. So instead of sign here, we have exponentiation of cos of x. So that's what we are doing. So we first took the cos values of the elements of x1 and then exponentiated each of those elements. And I think we are good here for example 2 as well. So let's see. Compile the code. It compiles well. Next, we run the executable, and we see we have two plots. This is corresponding to the first example, and this plot is corresponding to the second example we just created. Now see that here we have our x scale in log values, whereas the y scale values are in true scale. And we also see some problem in our y label naming, so it's because of this. So we have to put everything inside a curly bracket, and let's compile it again and see if everything is okay. Yeah, we have fixed our y label naming problem, and we also have the plots ready. So that's it for this video. Until next time, thank you very much.